Hi everyone, good morning. So this is the early hours of Sunday. So today I'm announcing a small project that can help people around who are interested in computer vision. So this computer vision masterclass is designed uh, with all the foundation concepts to advanced applications in the field of computer vision, and you'll be equipped with both theoretical and as well as practical skills. So throughout this course, basically what we are trying to do is we'll explore various modules covered in Python programming, mathematical foundations, machine learning fundamentals, and core computer vision, and then followed by a capstone project. So, what is the difference between this project and the other projects that you see across uh, different learning websites, right? So this is curated by industry experts. And also it takes you right from Python, learning mathematical foundation concepts, and how do you apply Python labs, how do you do Python labs and quizzes and everything. So let me take you to an outline of this course. So it has we have this welcome and course overview. So the course structure, objectives, career opportunities, and setup and assessment methods. So class 2 is about introduction to computer vision, where you will be knowing what are all the Python libraries or ML and mathematical foundations that you're going to learn. So the prerequisites for this course is so if you are very well versed in Python and maths, you can skip these courses. But I would recommend this to take further because a Python primer it covers lots of basic Python, also like data processing libraries and how do you launch a Jupyter lab and how do you run them, and then how do you run it locally with different data sets and everything. So it's covered mostly in it. So the maths primer actually focuses on because the computer vision requires certain mathematical foundations where um, how do you understand linear algebra, calculus, and like matrix operations, vectors, and and basically it also teaches about digital image processing. How do you apply filters and how do you enhance your images through mathematical models, and then and then apply the principles of OpenCV, and then you will get to know more about the details in the match panel. So once you are set with the foundation concepts of Python and mathematics, so basically we will take you to a three-step layer. One is to teach you about the supervised learning methods, unsupervised learning, and then third one is deep learning for computer vision. So if you see, I don't know how many of you know a Hugging Face. Hugging Face is one of the model hub where there are lots of open source models that are built in and written there. So let me tell you a different use cases of how a computer vision can be useful to you when you go or switch a career into computer vision. So this is one of the areas where there are lots of there's lots of lag in the developers that you see, because not many of the people are trained to equip this course yet. So if you seek to have a career growth in terms of understanding videos and images, where because most of the content is digitalized, and then introspection of the content is one more thing where you need to see how for example, in the case of image surveillance or video surveillance or face surveillance kind of projects, you would be able to use computer vision properly and then identify, what are the objects involved in it, what is the scene created around it, and then for example, in let's say you are putting an AI camera, so how are they going to detect the people, persons, like all these things. So in some countries we have personal data protection like a GDPR in Europe and DPA in Singapore, and then there are a few other things that are across places, right? So also governing to those rules, how computer vision can be really helpful in for you to shape up a career in the Gen AI space, along with the video and audio detections. So one good thing is about summarization of a scenario or a scene. Let's say you are seeing a video in a shopping mart, or like, so we wanted to detect if there is any non-payment of the goods, or if there any robbery or stuff like that. So it is easier for surveillance tools like these, computer vision, to detect it. And one other interesting thing is, for example, you want to you you have a warehouse and you want to do sorting and storing the contents. So how best is to design your warehouse, or how best is to design your containers in such a way that you can you can use computer vision in order to store and shape up, that you optimize the space. This is one more interesting example. So the third example I can say is, like, you have let's say in the production of certain seafoods, or in the for certain packaging structures, or you can easily identify like how they are being packaged, or how what is the quality of the food, or if it is using the image recognition techniques and image enhancing techniques, you'll be able to do that. So yeah, so in the core computer vision concepts, this is what we teach. So image processing and feature extraction, where you actually have if you are getting a bad images, or if you need to enhance your images and do feature extraction from the images. So this is one of the approaches where you do image processing, and then you do feature extraction from these images, and you attribute those features as tags, or like field vectors, and you use them for better enhancement process, right? So as I said, like, there are if you see, there are different sort of computer vision, like models, where you can actually enhance the image itself by its own nature. So for example, you have a blurred image, and you want to improve the image image structure to a better prospect, so that you can use that image in terms of like proper detection and recognition phases. So that's where the initial image processing, which is a digital image processing fundamentals, will be helpful in this case. So I'm talking about OpenCV for a while. So, but there are out there like different transformer models that have been trained. So YOLO is one of the YOLO stands for you only you only live once, right? So that's a segment. That's one of the model. So YOLO has come up from right from version 1 to version 11 right now. These are all quite enhanced models, where you would be able to detect people, persons, and then pets, even car plates, number plates, all these stuff in using YOLO. So, and we also involve semantic segmentation, where semantic segmentation is more about understanding the type of objects that you are actually recognizing, and giving attributes or metadata or parameters to it. So so for example, let's say i'm I'm in a conversation with a friend. So I'm talking about some things to him or her. So what's my mood actually? What's my so are the person really engaging? So all of these attributes actually, or happiness, or sadness, or like neutral phase. So all of these attributes can be easily determined using this computer vision things. So so these are the three modules that actually we are going to proceed in terms of the core computer vision concepts, but each one of them has its own significance in terms of um, identifying objects, and doing also motion analysis. Motion analysis is important thing in video captures, where if you want to track an object, or in a warehouse, or if you want to track a thing in a particular video. So motion analysis is one of the interesting parts that you get to. So as we progress in the course, So actually, we will stick to four different segments. So let's say you want to build a model for dealing with autonomous vehicles. Uh, we can see there are more autonomous cars, and people are training this for quite some time. But what we're going to do is we're not going to use all the autonomous vehicle features, but rather we can develop some specific module to detect certain certain movement in the cars, and then certain navigation directions and stuff like that. So medical imaging is one more interesting part in the field of computer vision, where mm, you have complete pictorial image. For example, you're doing invasive operations. Invasive operation is where, like, so the doctor sees in the camera and then finds out, okay, what it exactly looks like, and then operate it with a specific robotic based approach of, of the, so that in that space also computer vision is quite used to a greater degree, right? So, and also pre-detection of diseases and analysis in the medical scans. So because with X-ray and full scans, you would not be able to identify the complete picture of the, but with the latest advancements in computer vision, since the medical imaging has taken to a different level, so analysis of these things, or for example any abnormalities or anomalies in the organs of the body can be detected using the medical imaging process that computer vision uses. Yeah, as I told, robotics is one more thing where you can see tiny robots actually doing the things using the vision-based characteristics. So they would be able to navigate, they will be able to do object manipulations, and they will be able to react to situations and surroundings based upon the vision modules. So the last one is security systems. For example, let's say you have a you are guided by digital locks, and then digital cameras, where you can use your photo scan to unlock your own home or unlock your own devices that are present inside your home. So this is, or for example, like, let's say you have um, some components like Amazon Alexa or Google Home or Apple Siri. So all of these are used for security systems, where you can unlock and or certain commands which can make your life easier and automated. But yeah, at the same time, security systems are one thing where you need access control and detection. So access control and detection back, I mean, during the times, from how do you log into the systems using username and password. Now there is new advancements for passkey, or like sending an OTP to your phone, or validating yourself with biometrics, and more recent advancements there, you will be able to do with retina scans and everything. So all of these things are possible now. But at the same time, for example, you want to monitor your own properties, what's happening out there, and run real-time alerts, so that you will get notified when there is a problem, and then you can inform the authorities of what's happening around your house in case of any problems, or in case you want to make yourself secure. So basically, these are the self-signed and then they abide by the PDPA rules and then the GDPR rules, but also and then those kind of security systems is what we wanted to build as a future engineers, right? So um, so both video based security system as well as a camera, like image based security system, can be can be the future of our things. So in this also, like, you will be able to do facial recognition and anomaly detection in the surveillance. So these are quite rapidly used in the current world, because if you see, apart from the text, right, images and videos are the most images, videos, and audios are the most the next generation content that you're actually being produced. So for example, you want to find out what are fake arts, right? Deep fake arts that are coming out what so there are algorithms even to find out whether it's a deep fake art or a natural art. So where you so these are the various understandings of when you talk about computer vision in imaging, robotics, security systems, and whatnot. Yeah. So there are so you can pick up one of the spaces, and then you can um, go further into this segment. So yeah, so the next advanced topics in computer vision is like now with the VRs, virtual reality, and augmented realities. So the 3D vision is becoming popular because you would have to find so e-commerce shopping is one more interesting thing where images and 3D images and 3D visualizations play a key role in understanding the 3D based computer vision. So for example, in a similar situation I gave you, so a e-commerce warehouse where you want to do packaging, sorting, um, and then delivering to a exact endpoint where the the delivery person can pick up the parcel from the warehouse. So that's one of the interesting things about doing a 3D vision, and then depth perception and depth and breadth perception, and then height. Also, all of these stuff can be implemented using the 3D vision. So next is the GANs. GANs are one of the advanced techniques where you need to generate. You need to learn more deeper into the computer vision networks and image generation and manipulation. So so these are important because in order to understand the layers of the image particularly, or the layers of the video in particular, GANs literally play a lot of difference. So the next one is robotics. Basically, in robotics, you need to identify everything is in robotics. Everything is by defined by coordinates and the length and breadth and height of the pixel sizes, and then the image coordinates how it is moving across, because that's the way how a visual modeling robot can identify these techniques. So that's where specific focus will be laid on simultaneous localization and mapping the coordinates of the person or people it is in front of your vision module. So this is one of the key approaches where we will also go through in this advanced topics. So another so there are lots of resources and materials on our code. So what we also need in this course would be having a common, like a common data set library, like a data robot flow, like a robot images flow. So there are lots of images data sets around that, and then you would be able to sign up for that. Once we have these images in picture, so we can also use some real world images and train accordingly. So my interesting point of view in this is like, okay, so if you so these models act right, we can also build it on embedded devices. That's where the key difference comes into picture, because once a video surveillance starts, right, so you don't want to have a lot of lag in order to actually stream the video back and then give the real time notification. But what if you are able to build models on the edge? So this is where small language models come into picture. So we call them as SLMs. So LLMs are for large language models, and SLMs are for small language models. So once you have these small language models, so they are focused on defining certain parameters. Like for example, like a deep like let's say I want to do person detection on a camera. I want to do a pet detection on a camera. So these are the various attributes that it is trained for. So the footprint of the model is so small that it is easily deployable inside the embedded firmware, inside the embedded with the embedded firmware along with the camera. So maybe you can put a flash drive or a SD card, but you need faster processing. So that AI module faster processing thing would be written in some sort of language like C, or even we can write in Rust, and then we can use it for inferencing part. Whether, but the model would be trained on the persons, and so even there are like re-identification of the person. So this is not a complete one of the secure rules of GDPR, but person re-identification is like mostly, for example, if you see the same person before your doorstep, and then you wanted to mark as an attribute for him, like let's say there's some guy called Sam, there's another guy called John, there's another guy called some other X. So basically, you can mark the person. So whenever they come, you will automatically know. So this is one of the ways to. So these kind of models you can deploy it on the edge-based devices like on cameras, because already people are doing this one. So the this kind of knowledge, right? So basically, if you start applying on your projects uh, right from your early stage of careers, so it's completely a different segment of AI. And then start from, okay, my advice to, if there are students who wanted to take part in this, and if you are an experienced developer and but you want to change shift in your career, so, or if you are like already a data scientist and you wanted to advance more into the advanced topics, so where you can do it by yourself, using certain methodologies. But what we are going to provide as a part of this 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 program is, so we would want to give the right materials and right resources to the right people at different junctures of their career. So that's what we wanted to target in this module. So um, so having said that, so this is one of the streaming that's going on live, but um, yeah, we'll do a more formal session. So this is just to see how people want to react to this. Yeah. So later I will be sharing this across the different learning places as well as job boards. Whoever wants to take a career in computer vision. So even we can try to find out some Kaggle projects, and also we can work out together as a set of developers. Yeah. I would also recommend any insights or any feedback, so that we can incorporate it into this specific course. But later on, we will start with some sort of a Slack channel, and then also like a closed group where we whoever wants to subscribe to this, and then we start publishing in a Google Classroom, and then that's where we'll start to collaborate. So there will be an end of the session, end of the theoretical discussions and the Python labs and everything. So the concepts that I told you here, the applications of computer vision. So you're gonna pick up one of them, and then we will take some of the live world projects across the places, and then we start working on them, and then there will be an assessment. So typically this assessment, so what we are aiming for is a 20% of the primers is the course, and then some Python labs are graded differently, but does not fall under your final assessment. But the Capstone project covers almost 80% of the final grade. So there are regular quizzes, Python labs, and mathematical tests, and then the Capstone projects. So this is where we will start. So, there are a few books that we can recommend: computer vision algorithms and applications, and then models learning and inference by Simon Jerry Price, and geometric methods in computer vision by Fawcett and Pons. So you can refer to any other textbooks as well. So, but these are the textbooks which we mainly focus on, and then we try to do the exercises in the textbooks as well, and then see how we can interact with the current scenarios. And there are a bunch of online tutorials, and I can provide you the links to it, and then code repositories for CV algorithms as well. That's it. Thank you.